This is the second part of our lecture, Introduction to Data Analysis and Statistical Software, simply called Stata. My name is Faiza Wahib Adam. The outline of this lecture, we look at the nature of Stata, data management in Stata, descriptive statistics in Stata, what we call log files, do files in Stata, and then some work examples. Stata is a statistical analysis software which is very easy to learn. It's also a powerful software used widely in research. It has traditionally been a command line driven package that operates in a graphical windowed environment. Unlike SPSS, which is menu driven, as we saw in our first lecture. In Stata, most of the commands are command line driven. You type the command at the window, and then this is always better because users have control over the statistical outputs as compared to SPSS. So let's look at the Stata window. You first extract the file given to you. Maybe you put it on desktop. Then you double click on that. You see WSE Stata. Double click on. And then you have, so this is the Stata window. We have the command window where you type the command. The command window here. This is the history of the command. And then the list of your variables shown in this window. So here we have the command history, the results, the variable list, the command prompts, the working directory. The working directory, as in, if you take this example, you have C/document and settings /administrator/desktop and so on, and then log status, whether you are logging or not. And then we look at the Stata toolbar. In the toolbar you see open, save, print, log, viewer, graph, and so on and so forth. Now you can enter data in Stata by, if you want to enter data manually, you can do that by clicking on what we call data editor. Data editor, you see here, click on that, you have the window. Unlike SPSS, in Stata you can type the variable and the data in the same window, and here you can type something here, the first column, and that will be your first data. For instance, if your variable name is sex, you enter your variable names in the very first row, and then you enter your data in the columns beneath your variables. So here we have data of first variable, and then we have variables, and then there are two types of data entry again, as in SPSS. You do data manual. You can also do data import from any data entry software. And there are rules, all the rules of saving files follow, as we have in Word and other softwares. How do you label the content of a variable? To label the content of a variable, for instance, region, you double click on the variable, then click on modify, and then you can click on define, and you can define the content of the variables. For instance, if you take region, we have Western, so you can type the name of the variable is, the name of the label is Western, and the label is 1. The name of the second one is Central Region, Greater Accra, and so on and so forth. And after doing all of this, your data will be ready for analysis. And like we did in SPSS, here you do graphical displays, tabular descriptions, and summary statistics. There are some important functions and operators. Abs returns the absolute value, exp returns the exponential function, int returns the integer, ln represents the natural log, and so on and so forth. And then there are what we call logical and relational operators, and the first two are logical operators. We have and or and not, and then we have relational operators such as greater than, less than, greater than or equal to, less than or equal to. In Stata, we use double equal to when you are using when you are relating your. This is not an assignment. The double equal to is not an assignment as we have in other programming languages. In SPSS, the relational operator is just a single equal to, but in Stata we have two of them. Then we have not equal to also. Then you can create a new variable by typing gen, the name of the new variable is equal to the old variable, and then some math expression. This is the general syntax for creating variables in Stata. And then you can type help generate at the command prompt to see all the generate functions that you have in Stata. We can also create what we call percentiles in Stata. Percentiles will break the data into equal portions for us. For instance, quartiles will break our data into 4 equal portions. Quintiles will break our data into 5 equal portions, and so on. For all the other types of percentiles, you can type help percentile at the command prompt. Then how do you create tables in Stata? To get all the table commands, you just type help tabulate at the command prompt. Then you press your enter key to see the options. And then to draw graphs, we just type help bar, graph bar for all the bar charts options, help histogram for all histogram options, help line for all line options, help scatter for all scatter diagram options, and then help progress for regression analysis. And then a log file is a file that keeps record of the commands you have issues and their results during your Stata session. You can create a log file by just typing log using the file name. You can either append or replace your text. You can also type command log, that is cmd log, then using some file name that would give you a log of both your results and then the commands. And then we also have what we call do files in Stata, and this is a command just like a program. Maybe in MATLAB you can say this is like an M file, and then you type all the commands there and you can run it and you have your results. You don't need to be clicking anytime you have to repeat the same process. And then the default extension is .do, and if you want to type comments here, you can use the hash key and then double / or triple at the beginning of a line, and if it / and a hash at the beginning and at the end, everything typed in between is ignored. So let's look at one example. The first example says, with the aid of bar charts and tables, show the rural-urban correlation for the various regions. here we want to show the do and the log files as well. Yeah, let's look at our first example. Here, with the aid of bar chart and table, we want to show the rural-urban correlation for the various regions in Ghana. So we need a bar chart and a table. And so at the command prompt, you type, you first open your file. So you click on File, Open, and then we are still using the housing characteristics X7. Then you click Open, and we want a table showing the urban-rural correlation in Ghana. So we type at the command prompt. We type tab we want the urban rural, so that's log 2. For the various region, so you type tab log 2 tab space log 2 space region, and make sure the spelling for log 2 is as you have here. You can actually click on this, and then the spelling for region is this for the label, because that's what it would pick, and you can hit the enter key. Here we have urban rural, so it tells us in the western region the number of people in the urban and rural. You can rearrange the table by typing the region before the log 2. If you type tab region before log 2, you have all the regions and the number of people living in the rural and urban of Ghana. And then we can also draw a graph by typing at the command prompt graph bar count HHID over comma over region over log 2, and you should have the graph as shown. In the second example, we want to show the distribution of the usage of LPG as the main fuel for cooking in the urban areas of the various regions in Ghana. So for all the various regions, what is the distribution of the main fuel for cooking? What's the distribution of LPG as the main fuel for cooking in all the regions of Ghana? To do that, you type graph pi, and here we are looking at LPG as the main fuel for cooking. So we have to find the definition, the label of LPG in our main fuel for cooking, and then we also look at, we know region urban areas of Ghana is log 2 equals to 1. So we click on our data editor, and then we look for main fuel for cooking. Look for main fuel for cooking. That's S7DQ 13. can look at define, modify, and take main fuel for cooking. So we have wood, charcoal, gas, electricity, kerosene, crop residue, and then animal waste and other. And here we see that LPG is the fourth. The value for LPG is 4. So we type at the command prompt graph pi if S7DQ13 is equal to 4 and log 2 is equal to 1, and we are doing this over region, and if you type that, you should have the pie charts as you see on this graph. Okay, thank you very much for your time, and hope to see you later. Bye.